So let's talk about one of the very important technique in integral calculus, what we call the partial fractions method. So this technique is very useful not just for calculus 2, but if you are planning to take differential equations and other classes, you need this, especially when you try to do Laplace transform method. We're gonna go through a partial fraction method. So this is a very important technique in calculus 2. Um, so those problems, so what we call the, so what we can do a partial fractions method, partial fractions method. So in short, you can say PFM. So partial fractions method. Um, so we assume that under this technique, those integrals have this format. So this is the key point. So let's say you have two polynomials. So you're going to divide two polynomials. These are polynomials. So this is what we normally call a rational function. So we have a rational function. You divide two polynomials. So this is a polynomial. This is a polynomial. But there's a condition. So like for example, the degree of the denominator polynomial has to be larger than the degree of the numerator polynomial. So but what happens if this is the case? If the degree of the numerator is greater than or equal the degree of the denominator polynomial, what we gonna do? We have to do something. We're gonna divide. So that's what we didn't do. So we had to divide first before you apply the partial fraction method. So let's do a problem which has a higher degree to see what's going on here. So let's do this problem. But if you need more examples and more cases, you can look at the original video that was created for partial fraction method. That has a lot of examples, but here just the basics. So integrate. So let's say integrate this one. How about this 2x cubed plus x minus 1 divided by, let's say we have x squared minus x minus 2, because that's easy to factor. So something like that. And you can see the degree of the numerator is 3, degree of the denominator is 2. So that means you have to divide. So we're going to use the division, like the long division that we learn in algebra. So we want to make sure that we include all the terms. So x3, so there's no x squared terms, you put a 0 x squared. That's very important. Otherwise, it's gonna give a wrong answer. So like that. And then we can divide this one by x squared minus x minus 2. So if you divide, you can see that 2x is missing. So we're going to multiply by 2x all the terms. So it's 2x cubed. You see it's matched very well. And then negative 2x squared, and then negative 4x. So that's what you get, and then you subtract. Subtract means change the sign of the bottom one and add. That's the easy way to do it. So you change the sign and add, so you get 2x squared and then 5x. So that's what you get, and you bring the other term down, so you get negative 1. Now again, look at the first term. So you can see 2 is missing. So you can see 2 is missing. So we're going to multiply by 2, you get 2x squared is matched. So you need to match the first terms. So that's what you're trying to do. You try to match the first terms. When you subtract, that's going to cancel out. So that's the argument. And then you can multiply by 2, so you get negative 2x, and then multiply by 2, so negative 2. Actually, negative 2x and negative 4. And then what you're going to do is you're going to subtract them. So once you subtract them, what you're going to get is first term is 0, change the sign and add, so you get 7x, change the sign and add, you get 3. So that's what you get, because that's the degree of this one is smaller than the degree of the divisor, you stop. Okay, that's when you stop. The degree has to be smaller than the degree of the divisor. So that's the case, so you stop. Now what you can do is you can see, now you can write this as this. So when you divide, your quotient was 2x plus 2. That's the quotient that you can see right here. That's a quotient, so that goes there. Plus the remainder was 7x plus 3, but you have to write the divisor below it. So that's how you do it. So it is x squared minus x minus 2. So that's what happens once you divide. So you get the quotient and the remainder divided by the divisor. You have to write it in this form. Now you can see you can integrate simply. If you integrate the first term, you get x squared. If you integrate the second term, you get 2x plus what do you do with? We don't know. So that's where you need what we call the partial fraction technique. So so you get x squared minus x minus 2, and this is the part we need help with. So for that, and then now you can see the degree of the numerator is smaller than the degree of the denominator, so everything looks good. So let's see how to do a problem like that. Okay, that's where we're gonna stop. That's the key point. Once you divide, you stuck with something like that, and then you're gonna use a partial fraction technique to do that part. So let's look at a typical problem like that. So we can do all three types. So let's go with the type 1. Type 1 means a problem like this. Okay, that's a type 1 problem. So let's see how to handle this. So uh, yeah, so I'm going to say partial fractions. Okay, that's where we're gonna discuss that. So what you do, let's look at this one. So I'm gonna call type 1. So as a type 1, we're gonna see distinct linear factor. That's a type 1, distinct linear factors. Distinct linear factors. Distinct linear factors, that's we call type 1. So let's look at the same problem that we have. So so for example, I'm going to go with a typical problem. So type 1 problem looks like this. We have x plus 3. You have two distinct linear factors. So x minus a, x minus b. So that's the kind of situation we have. You have something on the numerator which is degree less than the denominator. Denominator here degree degree of the denominator is 2, because you have two linear factors, that means degree 2. So that's the kind of situation we're looking at. So what you can do, this has a typical partial fraction form. What you do, you write one linear factor, it doesn't matter which one, and then write a constant. The degree of the numerator has to be 1 degree less than the degree of the denominator. Okay, degree of the numerator has to be 1 degree less than the degree of the denominator. But you know that degree of the denominator is degree 1, so numerator has to be degree 0. Degree 0 is a constant. And we write a similar term like, so we write other term. There's no special order, so write b. So like that. So the goal is to find a and b. That's very simple. So this is what we call the form 1, the type 1 distinct linear factor. So you can have any number of terms. We just do the same thing, just write a single term for each different factor. Okay, so let's go back to the problem that we kind of got stuck. So we can integrate this problem, integrate this one, not the problem. So integrate 7x plus 3 divided by x squared minus x minus 2. That's the problem that we could not do. The first thing that we're trying to do is we need to factor the bottom. You can see the factors are x minus 2 and x plus 1. Those are two factors. That's what you need to do. And then those are two distinct factors, so very easy. So we're gonna write the form. So the form has to be a over one factor, let's say x minus 2 plus b over the other factor plus x plus 1 dx. The goal is to find a and b. That's very easy to do. So we can write the form. So x plus 7x plus 3 over, let's write the factored form now. So we have these two factors which is identical, not equal sign. Don't write the equal sign. Equal sign is logically wrong actually. It has to be identical because we're going to use the properties of identity. Identical to a over x minus 2 plus b over x plus 1. What we normally do is we're going to multiply both sides by this. That's what we normally do. So once you do that, you're going to get 7x plus 3 on this side, identical to, when you multiply the x minus 2, the bottom term get cancelled, you get the other one. That means you get x plus 1 here. The same thing the x plus 1 get cancelled, you get the other term. So remember, you get the other one. Even though you have many terms, exact same thing, you get the other one, you cancel the bottom term, write the rest. Now we can use the shortcut. Shortcut means you can use a substitution. You use a proper substitution to find A. So the goal is to find A, try to cancel this term. How to cancel this term? You plug in x equal 2. Once you plug in x equal 2, that term gets cancelled, so you end up getting A. So we can substitute x equal 2. Once you have x equal 2, you get here 7 times 2, 14 plus 3, 17 equal. Now is the equal sign A. So we have 2 plus 1, which is 3, plus 0. And this says that A equal 17 over 3. The same argument, you can substitute x equal, what's the best substitution you can do? You can plug in x equal -1, because if you plug -1, what's going to happen is going to cancel the first term. So if you plug in -1, you get -4 here. If you put -1, this is 0. From the b term, you get -3, because -1 minus -2 is -3. This is going to give you b value. So b value is -4 over 4. That means 4 over 3. Okay, so we find a and b. Now you go back and plug in those two to the integral, and you can finish the rest of the integral. So so we get this now. So we done with the finding the two. And now let's go back to the integral and simplify. So we have 7x plus 3 divided by x squared minus x minus 2 dx. But we find the partial fractions. So we have 17 over 3 x minus 2 plus 4 over 3 x plus 1 dx. Now you can see that you can do them separately. So the first is 17 over 3, you can take it out. So once you take it out, you're going to get the integral of 1 over x minus 1, which is x minus natural log x minus 2. Here also you can take 4 minus 3 out, so you get the integral of 1 over x plus 1, that is x plus 1 plus c. So that's what you get. That's perfectly fine, good answer. You can also combine if you want. When you combine, what happen, you know that these goes as powers. So what we can do, we can take the 17th power and third cube, cube root, 13th power and cube root. If you do that, this is a plus, it's a multiplication. You can write it like that, but this is like extra step. Yeah, so it's x minus 2. You take the 17th power, the first one, x plus 1, take the 4th power. Now you take the cube root of the whole thing, because cube is common to both. But this is the extra step and looks great at the end. Okay, so that's the integral. So that's the final answer. One of them, it doesn't matter which one, the top or the bottom. So that's the answer. Now, if you go back to the original problem that you stuck with, the very first problem that we're trying to do, now we can answer that question. So the problem was 2x cubed plus x minus 1 over x squared minus x minus 2 dx. But what we did, we divide that first. So what we did was we divide that, and then we get x squared plus 2x plus, and the remainder part give you this integral, so which is x squared minus x minus 2. But now we know how to do that part. So that means you can write the final answer for this problem as x squared plus 2x plus, in any of those forms. So it doesn't really matter which form. If you write the expanded form, you can write it like that, log x minus 2 and then plus 4/3 natural log x plus 1. That's how you do the original problem. Okay, so so it's not difficult, but you need to know how to do. When you have different linear factors, we can write the form and then find a and b. So let's look at the second type. So this is second type, what we're gonna call type 2. So what is type 2? You're gonna see repeated linear factor, repeated. So you're gonna have repeated linear factors. So you can have linear factors, but they are repeated. So let's look at a problem like that. That will be easy. So let's say 7x plus 3, no change in the numerator. In the bottom, you're going to see x minus 2. We have x plus 1 r squared dx. So that's what you have, and you can see that you have a repeated number is squared. That means x plus 1 repeated twice. So what's going to happen is we need to write the form first. So we have 7x plus 3 x minus 2 x plus 1 squared identical to, let's write the linear one first. It's a kind of good idea. Plus, now what we can do, we can write only one term, like you're going to start with the smallest term. So what is the format? That's the degree 1, so it's just a constant. Now what's going to happen is every other factor also has the exact same format as the smallest one. The smallest one is this one, that's the smallest one. So everyone else have the exact same format. That means it is just a constant, not a quadratic term, not a linear term. I mean, you can write cx plus d, but that's just a waste of time because you introduce one extra unknown that is not necessary. Okay, because you can show that you can always bring it down to this form. So we can write the form like this. So this is the second format, second type, I should say. That's the second type. Repeated linear factor, I'm going to call type 2. Okay, let's finish the problem now. So what's going to happen in this case, as we did before, you're going to multiply by the common denominator. So you're going to get 7x plus 3 identical to, write the missing term. Here you can see x minus 2 get cancelled. So you're going to get x plus 1 squared. And then in the next one, one of the x plus 1 get cancelled. So that means you're going to get x minus 2 and 1 of x plus 1, and here you get x plus 1 squared. The whole term get cancelled, so you only get x minus 2. So don't expand, leave it like that, because that's gonna be very helpful. If you expand it, you can lose the structure of this problem, and it's gonna be very difficult after that. That's one reason why some of the students get stuck and take too much time. This is one of the very easy problem. So I'm gonna always try to use the substitution first and make a wise guess. For example, so what is the best number that you need to plug in to find a? So what do you do? Look at the other terms. So you can see x minus 2 is common. Try to make the common term 0. To make the common term 0, you need to plug in x equal 2. So you plug in x equal 2, what happened? This side simply become 2 times 7 plus 3, that means 17. Here you get a, you plug in 2, so 2 plus 1 squared, that means 3 squared. So we can write, yeah, that's fine, 3 squared. Plus you can see this term is 0 and the next term is 0 because you plug in x equal 2. So you see this is gone, so you get a. So a is simply, you can take 17 divided by 9. Now let's try to find b. If you want to find b, you can see that if you look at the other two terms, there's nothing common. That means that's not going to work. So I'm not going to find b, I'm going to find c. So to find c, look at the other two terms and you can see x plus 1 is common. That means you're going to plug in negative 1 to cancel the term. If you plug in negative 1, this side becomes negative 4. You can see this is 0 and this is 0, and for c you're going to get negative 3 because you plug in negative 1, and that's going to give you c equal as before negative 4 over negative 3, that means 4/3. Good. Now we still need to find b. To find b, now I'm going to use the coefficient technique. So use the substitution first and then use the coefficient. So if you use the coefficient, I'm going to always use the largest term. Start with the largest term. Largest term is x squared. Okay, let's start with largest term. There's no largest term. X squared term here, so it's a 0. And you can see what's the coefficient of x squared. You can see when you expand, just do mentally, you can see you get x squared term, so the coefficient is a. In the other one, you can see when you multiply these two terms, you get a x squared term, so the coefficient is b, and that's it. You don't get a x squared times the other one. So that's it. So this says that b has to be negative a. That means the opposite sign, so it's negative 17/9. You can see it's very easy. You find ABC very quickly. Now what we can do is we can plug in those and finish the integral. So that means your integral is simply going to be 7x plus 3 divided by x minus 2 x plus 1 square dx equal, so gonna be go term by term. So a, which is 17/9, the integral of 1 over x minus 2, this is very easy. And then b is negative 17/9, integral of 1 over x plus 1, which is very easy. And then c, which is 4/3, integral of x plus 1 squared. That may be like a little confusing. The best way to do is bring it to the top and then you can do it. So that means finally you get 17/9 natural log x minus 2 negative 17/9 natural log x plus 1. And how to do this one? Bring it to the top. So it's just a basic problem after that. So that means, you know, that when you have x plus 1, x minus 1 and that constant like that, you can simply ignore that, because when you use a substitution technique, you can pick u equal x plus 1. Once you take the dx, you can see du equal dx. That means you can simply consider that term as x. If you consider this as x, this is like x to the negative 2. So you can simply create this one like x to the negative 2. So if you look at x to the negative 2, the integral is x to the negative 1 over negative 1. So we can use the exact same trick here. So that means this simply going to be is a negative. So that's the negative sign. You're going to get 1 over x plus 1 plus c. So that's the easiest way to do this problem, and try to understand this part. So you can, if you want, you can substitution, but that's just a waste of time. Just treat this is like x to the negative 2. The reason is you have a constant there. So if you have a constant there, you can always do that. Okay, so this is the type 2. So let's go to type 3 now. So let's do a problem with this. So type 3. So what's a type 3? You're going to have a irreducible quadratic factor. So irreducible quadratic factor. Irreducible quadratic factor. So what we have is, so let's look at a problem like this. So we can integrate 7x plus 3 over, let's say, x minus 2, something like this, x squared plus 4 maybe, dx. So just some numbers. So if you get a problem like that, what are you going to do? So you can see there's an irreducible quadratic factor. You can break this into linear factors with real coefficients. In complex you can, but with real. So what do? You have a different format now. So it is 7x plus 3 divided by x minus 2 x squared plus 4 identical to, first write the linear one. That's the easy one. We write it. We always do the easy one first, and then you can see you write this x squared plus 4, which is a degree 2 polynomial. So the numerator has to be degree 1 less. That means this has to be degree 1. So degree 1 means this has to be bx plus c. So that we have to remember. When you have an irreducible factor, the numerator has to be of this format. So that's the third type. And that's it. There are only those 3 types. Everything else you can bring it to one of those. So let's finish the problem now. So what we can do, we can write the form again. So that's a form, and then again we multiply by the denominator term on the left side. So you get identical to a, the missing term, which is x squared plus 4, and on the other side it is bx plus c. The missing term is x minus 2. Good. Always, if you get a problem like that, use a substitution first. Always the substitution first. So I'm going to go with the substitution. So you can substitute. What's the best substitution you can do? You can plug in x equal 2. If you do 2, you get a right there. So you can see if you plug in 2, so you get 17 a. If you plug in 2, you get 4 plus 4, which is 8, plus this is 0 because of the of this term. Now this gonna give you a, which is 17 over 8. Now see whether we can find, we can use any other substitution. We can see that you cannot do it directly like that, but you can still do a very good one. You can substitute 0. That always works to find one more coefficient. So you find x equals 0, you get 3 equal, what do you get? If x equals 0, you get 4a for the first one. From the second one, all the x terms get cancelled. You get negative 2z. You get negative 2c, and from the, since we know a already, you can find c. So this says that 2c equal 4a minus 3. So 4a. So when you multiply by 4, this gets 17 over 2, because you multiply by 4 minus 3. This says that 11 over 2. That means c equal, so this says that c equal, you divide by 11 over 4, because you have divided by 2, so 11 over 4. So that found, so we got a and c. Now we only need to find b. For that we can use the hybrid, so the coefficient technique. So we're going to go for the coefficient. So we're going to go with the that's always at the end. We try to use substitution as much as you can and then go for the coefficient. Remember the order. So there are no x squared term, which is 0. What is the x squared term? You can see a going to give you x squared, because ax squared, so that's one term, and the other one b x squared, so the b is the other term, and that's it. There are no more terms. That means b has to be negative a. That means negative 17. So you can see it's not difficult, it's very quickly you get all three. Now what we can do, we can substitute and finish the problem. So let's substitute those three now. So that means the integral gonna be 7x plus 3 x minus 2, and then we have x squared plus 4 dx. So we can write the coefficient first. So 17 over 8, the integral of x minus 2 dx, and then we have a negative 17 over 8x plus 11 over 4 divided by x squared plus 4 dx. Now what we can do is we can split. So what we normally do is we can split, but also do some so I'm going to write this one because we already know this. So what we're going to split. So you can see, if you look at the denominator, we have 2x. So we have x there. So we know the derivative of x squared is 2x. So we try to create 2x. That means we're going to divide and multiply by 2. So that means we can write this one as 17 over 16, because we divided, and we can write this one as 2x over x squared plus 4. That's the first term, dx. And the second one, we just pull that one out. Just write x squared plus 4 dx. Now you can see that you can do them very easily. From the first one, we have 17 over 8, natural log x minus 2. Here we have 17 over 16, just the natural log x squared plus 4. The reason is numerator is the derivative of the bottom. So this is coming from the 4 formula trick. So if you forget this, look at the 4 formula trick. That's gonna show you why we can do that. Because if the numerator is the derivative of the bottom, you can always write it like that. And this is the tan inverse function. So you have to divide by a equal 2. So that means 11 over 8. You divide by another 2. This is tan inverse x over 2 plus c. So 2 plus c. So that's how we do it. So that's the end of the 3 techniques. So I'm just going to do one extra problem just to show you how to handle some different problems. Okay, so this, I say extra, so this is like some how to handle like special type of problem. So let's see how to integrate a problem like this. 1 plus square root x. So if you get a problem like that, you can see it doesn't look like partial fraction, but we can make a special substitution. So we're going to say u equal square root x. That's that term here. And then we discuss these kind of problems in the strategies of integrals. So you can look at that if you need more of these. So what do you do? Take the derivative. So it is 1 over 2. So I'm going to write this. So you're going to get 1/2 x to the negative 1/2 dx. So you can write this one as 1 over 2 square root x dx. You can bring it to the other side. So that means dx is 2 square root x dx, not dx, du, in other words 2u du. So that means your integral now becomes 2u du, that's the dx, divided by 1 plus u. So you can see this is not that difficult now. So what we can do is you can pull the 2 out. You can write it like that first. This step is not necessary. Now I'm going to do a manipulation. So you can do the long division. So just use the long division, you get the answer. Long division. But we can do some algebra tricks. So what we can do, you can add and subtract 1. So you can write this one as you add 1 and subtract 1. And then you can see that now you can easily write it like this. So it's 2 times. You can see this is simply 1 minus 1 over 1 plus u. This is very easy to integrate. So you're going to get 2 times u minus ln 1 plus u plus c. So you can substitute for u. If you substitute for u, it is 2 square root x minus 2 ln. Since this is positive, I'm going to remove the absolute sign. So you end up getting this as the final answer. So you can do that kind of tricks to solve some extra problems that you can bring into partial fraction method like this. Okay, so this is the end of the partial fraction technique.